Hello, hello, testing, testing. Can you hear me? Look, if you can hear me, please just enter something in the comments. Right. Hi, I'm ready and I'm waiting for everybody to come. So please come quickly. Okay, I think I'll wait for 5 more minutes and then I will start. We have 9 people with us right now, so hi. Hi, welcome to this webinar on Fusion 360. So Fusion 360 is a software which you can use to create 3D models, and you can also simulate them, animate them, and do lots of things with them. So what you use Fusion 360 for is to make models which you can use elsewhere. So in our case, the use for this would be to make models either for simulating robots or for 3D printing, especially for 3D printing. It is very easy to use and very helpful for creating custom models. Right. So let's dive right in. So you can install Fusion 360 from Autodesk's website. If you wish to, you can do that and follow along with me. Otherwise, just watch, I guess. So if you are a student at a recognized institute, you can get, I think, a 3-year license of Fusion 360 for free. So you don't have to pay the annual subscription fees or anything. So when you open Fusion 360, this is what you see. So there is this view here. We are here in the design mode. So there's just this origin over here with 3 surfaces visible, and here you can see the same thing listed. We just have an origin, and all your various tools are up here, and there is something interesting here which I'll just explain in a minute. So if you wish to see what all files you have, just click over here, show data panel, right? And you can see various files I have. I just double click on any one of them and I can get that file out, and I can change projects and stuff from here, but it's not very important. So yeah, these are the various tools. This is the various components which are here. So now we can start. So the first thing which you want to know is how can you zoom, pan, and orbit. Zoom, pan, and orbit. So what that means is basically zooming, panning, and orbiting. One thing to note, if you are using Fusion 360, you definitely want a mouse. A proper mouse with a scroll wheel, 3 buttons, all that kind of thing. Otherwise, it will be very difficult to manage this. So to zoom, just use the scroll wheel. Up to zoom in, down to zoom out. And panning is this, by the way, this thing of just shifting your perspective, that is panning. To pan, just hold down the scroll wheel and move around. And to orbit, press shift and press the scroll wheel and move around like this. So apart from this, you can also choose your view from this tool in the top right corner over here. So what you can do is you can press home to get to the home view. You can choose any of the surfaces, top view, left view, front view, back to the home view. Now the way Fusion 360 works is that you start out by creating a 2-dimensional drawing and then transforming that drawing to get a 3D shape. So now we come to the next part, creating sketches, which are the fundamental building block of your design. And this is the most important thing, how to build sketches properly, how to use constraints properly. That's the most important thing when it comes to using Fusion 360 in an effective and fast manner. So to create a sketch, this is the tool, this create sketch thing here, the drawing with a plus. Click that, and now you need to choose a plane to create your sketch on. So you have an option here of choosing this plane or this plane or this plane. I'm going to choose this XY plane over here between the red and the green axes. Guys, speaking like this to an empty audience is kind of freaking me out. If you're able to understand what I'm saying, just type it in the comments. Alright? Kuch to bolo yaar, this is getting really freaky for me. I'm literally standing in front of a camera and talking to myself. So if you can just put something in the comments, that would be nice. Anyway, getting back on track. So now there are three tools which are the most useful ones here: the line, the rectangle, and the circle. So the line over here, you just choose the line tool, which is this, and you just like paint, you know. Yeah, so it's just like paint. You choose a line, you click, you drag, and yeah, that's how it works. So that's line. You can also just press L on the keyboard and you can draw a line like that, and I'm pressing escape to stop. Now you can also create a rectangle, so just click and click again and you get a rectangle, and once again like that. And you can also put a circle. Just you choose the circle tool and you can create a circle. But the thing is, so far I have not inserted any dimension for any of these. So let's see that again, this time with dimensions. So I just click drag and press the delete key to get rid of all the features. Keep in mind that deleting things is actually a bit dangerous sometimes, because the way Fusion works is it doesn't just maintain the current state of your model. It starts off by maintaining the entire history of the model. Everything is maintained in a timeline, and if you mess with that timeline, things can get a little weird. So once again, if I create a line, I can specify a length. So let's say I want to make a line of 150 millimeters, and I can also specify an angle. So I press tab, and let's say I want to make this at 45 degrees. Fine, just pan up a bit, and this is fine. And when I choose to create a rectangle, press R for that. Just click, and you can specify the dimensions here as well. So let's say I want 100 by 200 mm rectangle. And same with circle, you can specify, press C for circle, you can specify a center, and you can specify a diameter. Let's say I want 150 mm dia circle. Now observe that these three figures are in blue, and there's a special meaning for that. It is very important that you get this next thing. So now we come to constraints. So far we have made everything by specifying dimensions manually, and this is fine, but the way Fusion works is that it makes it very easy for you to update your dimensions or your shape, anything you want. You can update it really easily and in a very fast way without it totally breaking your model, which is something which makes it very unique compared to other softwares like, say, SketchUp. Now, the reason that these things are in blue over here is because they have not been constrained enough. What I mean to say is that they have some freedom. It is not completely bound. For instance, if I just click this and I click drag it, I can drag this around, and I can drag this around, and I can drag this around as well. So as a good rule of thumb, you want to be able to constrain your drawing as much as possible, and you should use the right kind of constraints for this. So here you have the various tools for creating figures. Here you modify them, and these are your constraints, these symbols over here. So I will just delete everything that's here and just show you. So this is the horizontal vertical constraint. So basically, if you apply this to a line, it will force that line to be vertical or horizontal. So let me just show you that. Suppose I draw a line like this, I draw another line, I draw another line, and another line, and now I've got a closed shape like this. So now what I can do is I choose this horizontal vertical constraint, I apply it to this, that became horizontal, this became vertical, this became horizontal, this became vertical. So now I've constrained this to a certain extent. I have not constrained it fully, so I press escape, and I can still mess with this because I have not specified the dimensions. So now if you want to specify a dimension, you can use this tool here, sketch dimension, and choose this, choose the edge which you wish to dimension, and just type in the dimension. Let's say I want 225, and another dimension, let's say I want this to be 150. Now but this is still in blue, even though we have specified the orientations of all the sides and we have specified the dimensions of all the sides. This is still in blue because we have not specified its relation to a fixed point. We have not specified its position, in short. So what we can do is we use the second constraint, which is the coincident constraint, which if you apply it to points or points in lines, it constrains them to be coincident with one another, intersecting or being one on top of the other. So I just choose that, choose this point, choose the origin, and now you see it is in black. Surfaces are in blue by default, but this border here, the boundary, the solid lines, they are in black, meaning this is completely constrained. And I can always change dimensions. I can make this 200 for instance, yes, and I can make this say 400, and that's neat. So we've seen the horizontal vertical constraint and we've seen the coincident constraint. Now the next one is the tangent constraint. So what I can do is I create a circle just out here somewhere, and if I choose an edge and the boundary of the circle and I just choose this tangent constraint, now this circle is constrained such that the line is tangent to it. This edge here is tangent to it. So it's not always clear which object is the one on which the constraint will be effective. For instance, if the circle was the one which is fully constrained and I was applying this, then the line is the one which would be moving. Like, I'll show you an example in a bit. So right now the circle is the one which is moving. Fine, I'll just delete that over here. Fine. Next is the equality constraint. If you apply this to two circles or two lines, what will happen is that those lines will become equal. So I can delete this dimension by pressing delete. Now I have just this, and I can choose this edge, choose this other edge, and force them to be equal. And that's nice. And it need not be that they are connected. For instance, if I make another random line out here, I can choose this, I can choose this, I force them to be equal now, and I can still move this around. This is not constrained in any other way, but it has to now be equal to that. See, I cannot change its length, I can only change its orientation and position now. So that's the equality constraint. Now let's say I just start off again. I make a line segment here, another one here, and I connect that. Now notice here that this last thing is actually an implicit application of the coincident constraint. Like at every step here, when I draw this, I draw this again. When I draw this thing here, automatically these two are coincident, and it progresses like that. Fine. So now the next constraint is the parallel constraint. So I can choose this and choose this, and they become parallel. I choose this and choose this, and they become parallel. And I can still mess with it a bit, but not as much as before. The next constraint is the perpendicular constraint. So this and this, I choose that, that becomes perpendicular. And if I choose this and make that parallel, that becomes that. This can move around here. And in case you're wondering why we are doing things this way instead of just defining every dimension and going ahead with that, just bear with me for a few more minutes and I'll show you exactly why. Constraints are, I would say, the cornerstone of this software, and using constraints properly can help you design much more effectively. So let me just delete that and that. Now this is the, and now I'm skipping over this because this is actually a rule breaker of sorts. You should not use the fix unfix constraint because it is like a hack in the sense that it's not really useful. You're just constraining something to be fixed. You're not using constraints the way it's supposed to be used. So I'm going to skip over that. Fix unfix, we are not going to use that. Next is midpoint. So I just do this. I can choose this point, choose midpoint, and I choose this line here. Now this is constrained to the midpoint. That's another useful one. Next is the concentric constraint. We have concentric and collinear and symmetry, and this one I don't know what to do with. Anyway, so now I'll show you what we can do after we have got our sketch. So I'll just delete this and I click finish sketch. There are three things you can do with sketches in general. You can extrude them or revolve them, extrude them, revolve them, and sweep them. So extrude is really simple. Let me just change my view a bit here. To extrude, press E and you get this dialog box over here, and this. Choose the surface which you wish to extrude and do this. So what happens is, it's like creating a prism of sorts. A prism where you have the thing defined on X and Y axes, you have the shape defined on X and Y plane, XY plane, and you just give it some depth in the Z dimension. That's how extruding works. And I can choose a dimension here, say 1000. No, let's not go that far. 300. Yeah, 300 units, like that. And if I go back to my sketch now, I just right click, edit sketch. If I change this dimension here, let's say I make it 600 and I finish, then the dimension of the extruded prism that also changes. This slab here, its dimension also changed because whatever sketch it is derived from, the dimension of that changed. Now I can start showing you why constraints are so important. So let's say I delete that. Now using constraints the right way can mean the difference between having a very slow development cycle or a very fast one. So let's say I just create a sketch here. I create a circle centered at the origin of 100, small one. So now my intent is to create a pipe of thickness 5 units, 5 millimeter thickness pipe. Now there's a dumb way and a smart way to do this. The dumb way for me is to create, let's say this first circle was supposed to be the outer wall, and now this second circle I do this. I choose 90 as the diameter of my second circle, finish sketch, and I choose this and I extrude it, and I have a pipe of 5 mm thickness of outer radius 100 mm, outer dia 100 mm. Now let's say I want to change the outer dia. Edit sketch. Now I change this to say 200 and finish. Now this is not what I wanted. What I wanted was a pipe of thickness 5 mm. This has changed it completely. Now the smart way of doing this is something different. Just Control Z my way across. Now the smart thing to do is I create a circle of unspecified diameter. I take a line here from the center up there and extend that, and I dimension this and I choose the dimension as 5. And now I extrude this up to how much ever I want. And now when I go to the sketch again and I change the dimension of the other circle also updated automatically, and as a result the dimension of the body as a whole has also updated automatically. This is very important for you to grasp, that when you apply constraints properly, you can very rapidly change dimensions in your figure without it adversely affecting your model. That is, it will affect your model in precisely the way you wanted it. So the thumb rule for using constraints properly is, whatever is your intention, directly translate that through your constraints. For instance, I wanted a 5 mm thick pipe. So that's what I defined. I defined a circle of some outer radius. I gave it a 5 mm thickness and made a smaller circle. Instead of that, if I just make two circles with different diameters which have no relation to one another, that was the wrong way to go about it. So the bottom line with constraints is, whatever your intention is, translate that into the diagram through your constraints. Let me give you another example of how to use them effectively. So let me just delete this, delete the sketch, and now I will start off with a simple sketch here. Sorry, wrong. Control Z. So I delete this sketch and I choose this. I create a sketch over here. And again, at any time if you have any doubts, just put them in the comments. I am watching the comments. So just choose some dimensions. Let's say I create a rectangle. I dimension it 150 I dimension this to 50. Fine. And let's say I create a slab again of some height. Now I can choose any of the faces of this slab and make a new sketch on that. So let's say I choose this face over here. I can create a new sketch over here. So I choose this face, I choose create sketch, and observe that the boundary of the slab along this dimension has already been inputted as a drawing in here, and I can manipulate that. So let's say I create a line here. Now what I want is, I want two circles. I want a circle here and a circle here, suppose, and I want them to be equal. Now the smart way for me to do it is this. Now observe this, when I hover near the midpoint, when I see that triangle over there, I don't know if you can see this, I can create a line which is automatically constrained to that. And I notice we have a question, offsetting is a better option in cylinder case. That's what I wanted to do. Hang on, let me just get there. That's what I wanted to do. If you want to do something, define your constraints that way. Not right. I hope that answers your question. Getting back to this, so now I've got this shape over here. I can choose this edge here. Now one thing you can do with these lines is you can make them dimension lines instead of being solid lines by pressing X. Now what happened here is that it became a dashed line, and that's helpful because sometimes when you have too many lines, you want to be able to demarcate the lines which are a part of your figure and other lines which are just there for helping you draw and stuff. So if I make this a dimension line over here, fine. Anyway, so what I wanted to do was make two circles. So I just make this line over here, this line over here, and I draw a circle over here, and let's say I choose some dimension for this circle as 50. Now I make another circle over here, and I choose the two circles. I choose an equality constraint, finish sketch, and I can extrude these. Extrude like so. Now let's go back to my first sketch, edit sketch, and let's say I want it to be way longer. Let's say I want it to be 1000 long. Now what has happened is those rods have also moved because of the way I defined the constraints. There was a midpoint constraint over here and another midpoint constraint over here. In both the vertical and horizontal directions, there were midpoint constraints, right? So that's the way that worked. I can, as another demo, let's say I go back to my first sketch, edit sketch, and let's say I make it 750. That changed along with that. And now if I go back here, this thing here is like a history feature as such. It maintains the timeline of all the operations you have conducted. So what I could do is I choose some operation here which is there. I right click, edit feature. Instead of 125, I make it go up to 500. Okay. Observe how the other feature magically compensated itself. So that's something very cool. Now extruding is not the only thing which you can do with how should I put it, it's not only extruding that you can do with sketches. There are two other tools you can use. So I'll just delete this again, delete that. See, things break sometimes when you don't delete things properly. Delete sketch, delete sketch again. And now let's say I create a sketch here. Now what I'm going to do is a line of 700, and now I click create here. I choose arc, I choose center point arc. And I choose, let's say, 45 degrees. So, and I choose, let's say, 100. And again, I choose center point arc. And I just make that closed. Fine. And one last thing I add here is this line over here. I'll show you why in a second. Now you've seen the extrude tool. A tool which does something completely different is the revolve tool. So what it does is it takes some face and it revolves it around a specified axis. So this is the revolve tool. I choose a profile, I choose an axis, and it revolves it around that axis. So, and you can choose how much you want to revolve it by. So like you can go, let's say 90 degrees, 105 degrees, and you can go all the way if you like, and it will close that. So I choose 360 degrees, and you've got yourself a nice feature here like this. And I want to change it a bit, it's too thick. So let's make it 50 mm thick, and let's make it 60 degrees. And it updated itself. So you could use this as a lampshade or something, I guess. Next comes the sweep tool. And this is, I think, the most useful of the three construction tools which are there. So I'll just delete this. And I'll leave that sketch over there, it looks useful. And what I will do now is I will create a new sketch over here. So for the extrude tool, you just needed a surface and you can extrude it perpendicularly. For this revolve tool, you needed a surface and an axis. For the sweep tool, you need a surface and a path. So now let me define a path here. And let's say I just start off here by moving 1,000 units. Then I create another line over here, let's say 1,000 up, oh sorry, 1,000 Yes, and I create an arc, center point arc, like this. And I create another center point arc. Hang on, why isn't this constrained? Let me just do that properly. Create arc, center point arc, 90 degrees, and I create that over there, and I create another arc, and let's say take it, I had another 2500. Fine. Hang on, I'll just, yes, now we're ready. So now I have here a surface, this surface over here, and I have a path, and I want the surface to follow that path. So I can do this using the sweep tool. So I choose this surface and I choose this path, and the surface follows that path, and that's kind of handy. This is a very useful tool, and I've used it many times whenever I want let's say a flat surface, which is a surface which is flat in some parts and curved in other parts and following a particular path. This tool is very useful for that. It's the sweep tool. So you just create sweep, and if you want me to repeat something, just put it in the comments. I'm following them. If you want me to repeat, say, the sweep tool or the revolve tool, just put it over there, because now I'm going to show you a few different things. Right, so I'll delete this, and I delete that, and I delete that. Let's say I create a slab once again, and I'm not going to worry about dimensions right now because it's not what I want to show you. Now this is nice, but often when you're 3D printing, you want the vertical edges to not be so sharp, because that can create problems with 3D printing. So what you do then is you have two choices. One choice is you can manually create tiny arcs everywhere and then extrude, just keeping that rounded rectangle. So what am I saying here? What I'm saying here is that when I'm 3D printing, these vertical sharp edges here, they can cause a bit of a problem, because when the 3D printer is going, it is going in one direction and then it has to suddenly change direction again. So it's not smooth at all. So to avoid that problem, I have to make these edges rounded in nature. One way would have been to go back to the sketch, create tiny arcs everywhere, and then apply the extrude using that. But there is a different tool over here which is very easy to use. That is the fillet tool. So I select whatever edges I want to select, and the fillet tool is over here, and I just fillet it, and this is what happens. It makes the edges which are selected more rounded, and it takes material away or adds depending on how it is. Let me show you another example of this after this. So if you press OK, you get that, but I will cancel that and I'll show you another example. So let's say I create a sketch here and I create a rectangle here of some dimension. Let me call it 600. And I make that equal as well, and I do that. I make this equal to this, and I finish the sketch. And now what I can do is I can extrude this, and the extrude function does not always create new material. It can also remove existing material. Like in this case, you can choose here. I can choose join, cut, intersect, new body, new component. There are many things here. So right now it's using cut. So I've created this void over here, and now these edges especially, you can see why they would be problematic for 3D printing. So what I can do is I choose these I choose these 4 edges here, and I choose the fillet option, and it does this. So let's say I typically just put I think a 5 mm fillet. It doesn't show up here, but let's make it more visible. A 25 mm fillet is more than enough. 25 mm radius fillet, and outside you can fillet those as well. And we're done with that tool. This is very useful and it's also useful for another thing. Let's say you have many components which need to fit together precisely. There will always be tiny errors when you're 3D printing or doing something like that. So when you have those tiny errors, they tend to have maximum effect at the corners. So let's say you're stacking up let's say I move this and I create a copy. I'm using the move tool over here, and I'm creating a copy. Let's say I want to make hundreds of copies of these stacked end on end. Now if I don't have this fillet over here, tiny errors in the way this is printed can have a huge effect on how well they stick together, and there can be errors over here. So if you want to minimize the effect of those errors, you should use fillets. And there is another interesting tool, which is the shell tool. So I delete those, I delete the sketch, I delete this sketch as well, and I will make a new sketch. And I make another slab. Now let's say I'm not interested in having a solid block, and this can be a very common thing. Let's say I just want walls. I don't want a solid block. Now one way I can get just having walls and not having a solid block is I can manually create another rectangle on this face, and I can cut away material. But there is a far easier tool, which is the shell tool. So I choose the shell tool, I choose a face, and I choose my wall thickness. Let's say I make it 5 mm. So you can see there's a very thin wall over there. let's make it more visible. Let's say 250 mm thick. So now what happens is it has created a shell which has the outer dimensions same as that shape which was there, that cube, and it has a wall thickness of 250 units, 250 mm. So these four walls as well as the bottom, they are 250 mm thick. And this is really useful because many times when we are printing or designing something, we don't really need to have all that material inside. That is just a waste. So we can get away with it by using the shell tool to make our model. And there are a couple of other tools which are there, like there is I've already showed you the move tool, move/copy. You choose the tool, you select it, and you move along like so. You can choose to create a copy. I see we have a question here. So the errors are with respect to 3D printing. I'll just move back. So now I have a question here which says, I don't get the concept of the errors appearing without the fillet. Could you explain once again? So the thing is, suppose you're 3D printing something and you come to this corner, and let's say you want to create 50 of these things and stack them in a grid. Let's say I want to put them in a, hang on, let's say I want to have these in a grid like this. Okay, so if you want to have these like this, and let's say I want to have them sticking to each other, so oftentimes what will happen is at these corners there will be sometimes a lack of space because of a 1 mm odd or say half mm error. So that error would be introduced during the 3D printing process. So now if you don't have fillets, you cannot get a perfect fit over here in this corner space like this. Fine, but if you add the fillets, there is this extra space which is available over here where we can probably make this thing over here. And this is a very real problem. There is a project which you know, a student it's there in the Enigma lab. At least last I checked, it was there in the Enigma lab. Those who have seen it would be knowing Pranav Bhaiya's project, which is there on his desk, where he has something very similar to this, and he faced this exact issue where they were not fitting properly because of fillets. So I hope you got that thing. So I'll just delete these and get back to what I was doing. So I've shown you the shell tool and the fillet tool. And there are many other tools. There's the move tool. You can split body along face. You can do various other things, and it's all real interesting, but time is short. The last thing I want to show, the last few things I want to show, they are not related to designing, but they are related to simulations. And a problem which typically comes with 3D printing, and here we don't really do 3D printing for decorative purposes. We want to use the models we create and put them to some practical use, say creating a robot or creating a particular component which we need. So for that, we need to be sure that our model is strong enough to withstand whatever forces are present when it is running. For instance, if you have a robotic arm, you want to be sure that the arm will not just warp or bend under stress. So how do you do that? There is a very nice stress testing module which is available. So for this I will demonstrate with a simple bracket. Let's say you have a holder for a shelf, and I will create that over here. So let's create a sketch, and let's say you have 20 centimeters, and again the same amount. And I will give it a 5, no, let's make it a 20 mm thick wall. And let's make it 40 mm wide. So I've created that, and I'll create another sketch over here. And I will create 2 small holes over here. And I cut. Great. So our model is ready. So now I have this bracket over here, and I want to put a shelf on top, and I want to be sure that this model will not deform under stress, and I want to 3D print this. So I will now change the material of this. So I select the body over here, and I right click, I choose physical material, and this thing comes up over here. You can choose from fabric, flooring, glass, metal, but I want to choose plastic because that's what we use for 3D printing, and I will choose ABS plastic. Click drag across, and as you can see the material has changed. Great. So now we have this in ABS plastic. Now I changed my view from design to simulation, and you have various options over here like static stress and thermal stress, structural buckling, nonlinear static stress, shape optimization, all interesting stuff. Let's go with static stress for now. So now again over here you add some kind of physical constraint different from the design constraint which was there earlier. This is a, let's say I have 2 nails which I want to put here, and I will apply a force over here on this face. So what I do is I choose this over here, this surface and this surface. I choose constraints, structural constraints, and XYZ fixed. Okay, so now those are fixed in place. So that's one constraint I have applied, and now I want to apply a load for stress testing. So let's say I apply a force along this perpendicular to this face. So what I do is I select this, I choose load, structural load, and let's see how much would be ideal. Let's say I put 100 newtons of force on this. 100 newtons has been applied. Now there are 2 steps which you must follow. So solve, generate mesh, that's the first step. And the next step is solve, and you choose solve, and you have to save the project, and it will take some time to solve it. It will take a few minutes. So now what will happen is it will go there and simulate the effect of having, say, 100 newtons of force applied to that object, and then it will show you the results. So the constraint I applied over there is similar to the effect of having, yeah, see, now you can see that this says that it is safe to use this, which is nice. So actual adjusted, so you can see there is a mild deformation in this, and this is an exaggerated view of the same deformation. We can adjust that. So now you have various options over here. You can see what it is. So now it's showing us the safety factor, and we can view the stress, and you can see the stress is maximum here above the this point over here where we actually hinge it, where we bolt it, where we nail it to the wall. Right above that is where the stress is maximum. And displacement, you can see maximum displacement is actually over here, and maximum reaction force is over here, maximum strain is over here. Now let's say I create a new study again of static stress. Again I apply the same load, same constraint. I apply a different load, I mean same type of load, but let's say this time I go to 1000 newtons. And as you can see, there are huge problems with applying 1000 Newton force along with these constraints over here. So now let's see the stress. There's a huge stress over there. And there are huge strains over there. And there are issues here, and you can see the deformation, the actual deformation. I've chosen the actual deformation here. It is a very large deformation, and this is how it was without the deformation. This is the actual deformation, and you can see that the deformation is very large here, and this is very useful. So I know that if I want to use this thing with 1000 Newton load, I probably have to make it much more robust. I could increase the thickness, or I could add a rod over here diagonally. There are many things I could do, but this is useful information. But you should note one thing when it comes to 3D printing: a design that is dangerous in regular ABS plastic will almost certainly be dangerous when you 3D print it. in terms of the stress and the safety factor, but a design which is safe in this can still sometimes be dangerous in terms of the stresses in 3D printing. That is because 3D printing is not a usual way of making things. There are some differences. It is literally adding layer on top of layer of plastic. So sometimes the layers don't have enough cohesion, and in that direction the actual stress it can take is sometimes very less. Yeah. So now you have seen how to draw sketches in Fusion 360, how to make useful 3D shapes out of that, how to update those shapes, how to change the constraints, how to simulate the model, and with this much you should be able to do a fair amount of work in Fusion 360. Are there any questions right now? Do you have any questions? Okay, cool. I'll end the stream now. Thanks.